Hi, this is Amy Lewis. This is Engineers Unplugged. Hi, this is Amy Lewis, and we're back with an incredible episode of Engineers Unplugged. We're talking about storage is the new black. So I've got Vaughn and Chad, and they're bringing sexy back to storage. I'm going to let, you've got to see this one. Vaughn, take it away.
Great. Amy, thanks for having us. Chad.
Bringing sexy back. I like that, man. That's great.
That's right. Storage is the new black. Storage seems to be the topic on top of everyone's mind here at VMworld this year. Lots of developments going on. I think it's fair to say disruption. Massive disruption occurring in the industry. So let's level set before we jump into some of the topics that we want to talk about here today. I think by and large, the customers are facing two primary elements in their infrastructure. First is the volume of data that they're dealing with, as well as the fact that most of their systems are virtualized today. And those access methods, combined with the sheer amount of capacity, that data that they need to address, is really putting a strain on the traditional storage systems. And as such, right, engineers being
when there's a problem, engineers want to solve it, right? And the other thing that is fascinating is that when it's in that virtualized context, the fact that they historically needed to talk to a storage team that would always be slow and conservative, because if they broke something, they would break it really badly. That also created a lot of tension, which comes back to that, primary use case is cloud and virtualization. So, as we were talking about it, the thing that is the sexy topics, we think there are three. So, flash, and we're going to talk about flash in a great amount of detail. Distributed DAS, we'll talk about this in a little bit and maybe save some for another episode. And then software control planes. So why don't you talk a little bit about what you're seeing in the world of flash, and I'll add in some stuff as well.
Great. And so for those who missed it, I do want to give a little bit of a plug. Chad and I will be talking about, as we do every year, storage best practices with virtualization. But specifically this year, we're going to be talking about software-defined storage and more of this software control plane. So if you have a chance to go online, check out our session from VMworld this year.
It is STO 5368.
Mine like a vice. So let's start with the area of flash storage. I think by and large, everyone understands that they need some element of flash in their infrastructure. Flash provides a vast amount of IOPS per device. It is the cheapest means on a per IOP perspective of adding performance and scale to your infrastructure. So then the question becomes, where do I add flash? I can add it inside of the array and help take load off the back-end disk drives. I can add it higher up in the stack in the network or in a host and take IOP load off of the array itself, or I can start to look at a means of running an all-flash array. I think in all of these scenarios, customers are looking for ways to reduce the price of flash because on a per gigabyte or capacity basis, it's quite expensive. And so they need to look at ways of implementing this technology in some form of caching, or as a primary storage device, a means of reducing the amount of capacity through data deduplication technology so that they can make that primary array affordable.
So when talking to customers, a lot of them think that we're just, all vendors are making stuff up to try to push this flash thing. Literally, if someone came to you and said, I could give you petabyte Ethernet for the same price that you pay for 1 gigabit Ethernet now, you could imagine that everyone would say, yeah, I'd like some of that. Flash really is 10, 100, sometimes cases even 1,000 times cheaper per I/O per second than magnetic media. So it's a fundamental disruptor. And fundamental disruptors get used in all sorts of ways. As you said, on the server, in the arrays, and in these new all flash arrays where you can see startups all over the place like Pure, like Extreme IO, like others, right? So lots and lots of cool stuff.
And one element that I would add to this is sometimes when we're talking about flash, sometimes there's a misunderstanding, I would say, where someone thinks it's only for the most critical or the most I/O demanding applications. Understand that adding IOPS to any system increases scalability, whether that's scalability within a single application or across a large number of virtual machines. Okay. Now let's talk about the second area.
So this is a funky one. Seeing a lot of interest in these new distributed DAS architectures. So these are basically models where you use the storage that is within the server itself, and that could be magnetic media, it could be flash media, any or combinations of the two. and via some sort of software method, usually connecting these servers using something like 10 gigabit Ethernet, you create a shared storage device that blends compute and storage. So examples of this would be vSAN from VMware. EMC's got something called Scale.io, but there's other companies that are also in this space too. Like if you think about how Nutanix works or how SimpliVity works, they're these distributed persistent storage layers that are still transactional. These are neat, and in the same way that these have got a lot of engineering innovation, there's a lot of engineering innovation here about how do you deal with the fact that certain IOs, when they're local, are very low latency and very high performance, but invariably some of the IOs are going to be non-local. You're going to need to make 1 or 2 hops across a higher latency network. Even 10 gigabit Ethernet has got relatively high latency for an internode hop. So lots of neat stuff there that I'm seeing in a lot of customers.
And we should add, whether we're looking at, say, a caching model where we're adding cache to spinning disk, or in this distributed DAS model where I'm combining local copies of data as well as remote, most of the data is usually served out of the local or out of the cache access. It gets a very low response time, great performance. Yep. When we have to hit that remote node and we add the latency, it's not like we always have outliers. If I've got a serialized application, that outlying IOP or IO could actually back up other IO that may be local and may negate the local response time.
There's lots and lots of neat stuff there, lots of stuff to dig into here at VMworld, and we'll do a follow-up session on this one. Things like vSAN do neat things where they control the places where VMs go via DRS to try to keep the VMs on the machines that have their local stores. The other examples use caching. Very neat stuff. Last topic, software control planes. So all of this stuff fundamentally is awesome, but it has to be simple and easy to use, and ideally infrastructure would be invisible. People have been seeing this for a long time where people would make like vCenter plugins, would be like an early prototype of that, and it's still awesome. But more and more people are trying to use things like SPBM from VMware, which is a storage policy-based management. EMC's basically made a layer that abstracts all the way down through the infrastructure and can automate, called Viper. There's a whole set of stuff here where the storage community is realizing that ultimately control has got to be done in software and done in a very, very automated way at scale.
Yeah, I think the key there is simplicity allows you to scale. So whether we're looking at elements from VMware, EMC, OpenStack, for example, and we know this from our sessions, don't underestimate how many customers have still yet to adopt plugins from their storage vendors. Yeah. Simplicity is how you move your business forward. So with that, I think we're out of time.
Thank you, everybody. Thank you, Amy.
Well, you're not getting off the hook that easily. You two draw the best unicorns. So I think what I want to see this year, it's trendy. I want to see a flash unicorn.
A flash unicorn. All right.
Go.
All right. I'll do the head. I'll do the lightning bolt. Fantastic. So you're just going to draw the lightning bolt. All right. So unicorn is a giant, massive, sexy horn. And then they've got a nose and a mouth like this and some ears. This is more like a donkey, I think. It's looking like a moose, maybe?
It's a Canadian unicorn.
It's a Canadian. And then legs. And then it's got to be kicking. And that's a tail here. Flash!
There you go. It's I'm beyond words. The world's first flash unicorn. Once more, I shouldn't challenge them. They always rise to the challenge. Just like this, storage is the new black. It is sexy again. Thank you so much, Chad and Vaughn.
Amy, it's my pleasure. And by the way, when it comes to flash, Cisco Whiptail, yet one more example of disruption.
Yes.
Hey.
Forgot.
That's the unicorn at the end. We'll see you next time on Engineers Unplugged.